One of the central parts of a heat pump system is the reversing valve. This is the item, along with some electrical components, that separate the heat pump from a traditional air conditioning system. So the reversing valve is composed of three main parts. It has a pilot valve, it has a main valve, and it has a solenoid coil. The solenoid coil is an electromechanical device that controls the pilot valve. The purpose of the main valve is to reverse the refrigerant route through the indoor and the outdoor coils. And again, with heat pumps, we refer to the two components as an indoor coil and an outdoor coil, not an evaporator and a condenser, because the functions of these coils change depending if we're heating or cooling. The basic operation of the reversing valve can be compared to a solid cylinder sliding inside a hollow tube. Blowing in one end of the tube will shift the cylinder to the other end of the tube. This is how the cylinder inside the valve is shifted through pressure differences. By imposing the discharge pressure on one end of the reversing valve and the suction pressure on the other, the pressure difference will shift the internal cylinder towards the side that is connected to the suction pressure. In other words, we push it to the low side. So when we take a reversing valve that is cut apart, okay, this is normally all sealed, but in this case, this picture is with cut open. We have our pilot valve here. We have tubes that come out of a pilot valve and would normally be connecting to different ends of this tube along with the lines coming in. And we have a cylinder in here that slides back and forth depending on the pressure difference between each side of this. So when we look at a reversing valve, the center tube that's by itself is always connected to the discharge line from the compressor. That is always going to be our high side. The center tube on the bottom, okay, is always connected to the suction line. Then the tube on the right is connected to the outdoor coil. The tube on the left is connected to the indoor coil. And then you have your solenoid with two wires coming out of it. So again, the biggest thing is the reversing valve is what changes the flow of refrigerant, not the compressor reversing. The compressor always puts the high side out on the discharge and the low side on the suction. Okay, and they're always connected to the center tubes of a reversing valve. The main body of the valve is constructed with a permanent suction in the middle of the valve on one side and the permanent discharge in the middle of the valve directly opposite the suction port. The ports leading to either the outdoor or the indoor coil are on either side of the permanent suction port. When at rest, the sliding cylinder straddles the two valve openings. One of these openings is the permanent suction. The other opening is the indoor, okay, or the outdoor coil port. This makes whichever coil is connected to the permanent suction via the sliding valve the evaporator. The port that is not covered by the sliding valve when at rest is open to the permanent discharge port. This makes whatever port that is uncovered the condenser. Okay, and if you look at these pictures, you can see an example of that. Okay, we have our discharge. Okay, and if the valve is over pushed this way, you see it's straddling those two. Okay, so we would have our whatever is the evaporator. The suction comes through here and goes to the compressor, comes out of the compressor and comes back. It's through my discharge line and goes out to the condenser. Then if this changes position, you see this little slider inside that's white colored. If it changes position, it comes over here to the right side. And now what used to be the suction side or the evaporator is now the condenser. And what used to be the condenser is now the evaporator. So all we're doing in this whole reversing valve is using an electrical solenoid and a pilot valve to push this cylinder back and forth in the refrigeration stream just to change the components. What is the condenser and what's the evaporator? So in the heating cycle, the valve is de-energized, and again, some of the older heat pumps out there and has a little bit different configurations. So if you have an O terminal, it means in the heating cycle, the valve is de-energized. If you have a B terminal, the valve is energized for the heating cycle. So again, watch your terminal designations. But most often, the heating cycle, the valve is de-energized. The solenoid valve is de-energized and the control plunger's down, closing the bottom portion of the vent line that's connected to the right end of the piston. The top port vent line is connected to the left end of the piston and is open to the equalizing valve. So what's happening here, okay, we have our discharge. This small pilot tube allows valve from the discharge, pressure from the discharge portion of the compressor, okay, to come out here, and it pushes the solenoid from this side and it pushes it into heating mode. This allows pressure to bleed off from the left end of the piston to the permanent suction line. It creates a pressure difference greater across the left side of the piston, and it causes the valve to travel to the extreme left, repositioning the slide valve to align the control port from the outdoor coil with the control port leading to the compressor suction, making the outdoor coil the evaporator. And again, let me jump back here. So, discharge from compressor comes through the center port and goes to the indoor coil, which is now the condenser. We take heat off the condenser and blow it into and it's transferred to the airstream inside. That's where the warm air comes from. We come out of there, okay? We come out of there and we come to the outdoor coil, which is my evaporator, okay? We come out of the outdoor coil where we've now absorbed heat, and we come back to the suction line of the compressor. Now, okay, if we go this, so this is a close-up view of the de-energized during the heating cycle, okay, just so you see how this works a little bit closer. The same movement also aligns the compressor discharge with the indoor coil, making the indoor coil the condenser. So again, you see that there's a path from the discharge to the indoor coil, and there's a path from the outdoor coil to the suction line, because the valve is all the way over to the left. Now, if we energize the valve, okay, now we've energized the valve. Okay, you see that this body from the left is my heating, the right is my cooling. So you see the four-way pilot valve has now energized and it's pulled the plunger over to the left. So my discharge gas from the discharge side of the compressor is now putting pressure on the left side of this, and it's going to move the slider all the way over to the right. With the solenoid valve energized, the control plunger lifts, closing the top port vent line connected to the left end of the piston. The bottom port vent line connected to the right end of the piston is open to the equalizing line. This allows the pressure to bleed off the right end of the piston, which causes it to travel to the extreme right, which reverses the function of the indoor and outdoor coils. High efficiency units have less pressure difference between the high and low side. This pressure difference sometimes causes the reversing valve to get stuck halfway through a shift. When this happens, the high and low side pressures will equalize through the valve. Valves with 4 pilot tubes instead of the usual 3 were designed to attack this problem. So again, the pilot tubes are not the main tubes we're talking about. The pilot tubes are these, okay? And they basically duplicate this little slider basically duplicates the main reversing valve. As before, the pilot valve shifts the suction gas to either side of the valve. The extra 4th line on the pilot valve goes to the discharge line and shifts discharge gas to the opposite end. Instead of relying on a bleed port for the high pressure gas, it is carried via pilot line directly from the discharge line coming into the reversing valve. Reversing valves can easily be damaged if struck by a hammer or a wrench. The valve has a relatively thin copper or brass body, and if it bulges into the slider, it's not going to work. Some technicians feel that a stuck reversing valve problem can be solved by striking it to try to free it. Striking a reversing valve with anything can cause more damage. Never strike a reversing valve. If it doesn't work, replace it. Now, one additional thing with troubleshooting reversing valves is this whole point about not having enough pressure difference. This also happens if you have a low refrigerant charge. A reversing valve will not work properly if there is not enough refrigerant in the system to cause a pressure difference. It will also not work properly if there is a TXV or an expansion valve that's not working correctly. So before you take the time and everything to unbraze, put in a new reversing valve and everything, make sure your refrigerant pressures are high enough to cause a pressure difference, and make sure that your TXVs or other expansion devices are working properly. Reversing valves don't normally go bad on their own. And also ohm that solenoid out. I think that's the only other thing. Ohm the solenoid out and make sure it's actually working.